Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISSP Squared CISSP exam with focused explanations and practical context. Today's episode explores secure APIs and service integration, two essential components in modern software systems that enable communication, data exchange, and interaction between services and platforms. As organizations embrace microservices, cloud computing, and digital transformation, the role of APIs in secure architecture becomes even more critical. However, with great flexibility comes significant responsibility. APIs are among the most targeted attack surfaces, and improperly integrated services can open doors to unauthorized access, data breaches, and cascading failures. As a certified information systems security professional, you must understand the risks, controls, and best practices associated with securing application programming interfaces and service integration points. Let's start with the basics of API security. An application programming interface, or API, acts as a messenger between two different systems. It allows applications to request services, exchange data, and perform functions remotely without exposing internal logic or databases. In many systems, APIs serve as the glue that connects mobile apps, web portals, cloud services, and internal systems. Securing APIs means protecting them from unauthorized access, data tampering, injection attacks, and resource abuse. Without proper security measures, an API can become a major vulnerability, exposing sensitive data and critical business logic. API security includes multiple layers of protection: authentication, authorization, data validation, transport encryption, and monitoring. It also involves secure coding, secure deployment practices, and documentation control. Every point where an application receives, processes, or sends data must be governed by security policy. When properly secured, APIs maintain system reliability, protect private information, and support your organization's compliance posture. Understanding API security fundamentals ensures you can defend the services that power modern infrastructure. Now let's explore some of the key threats to API security. The most common include injection attacks, such as SQL injection and command injection. These occur when user-supplied data is passed to a back-end system without proper validation or sanitization, allowing attackers to execute unauthorized commands or manipulate databases. Broken authentication is another major threat. If an API does not correctly verify the identity of the requester, or if it uses weak mechanisms like hard-coded credentials or basic tokens, it can be exploited by anyone who obtains the necessary information. Improper authorization is equally dangerous. Even if authentication succeeds, the API must ensure that the user has permission to access a particular resource. Without this layer, attackers may access other users' data or perform actions outside their role. Excessive data exposure is another problem. APIs sometimes return too much data, such as internal IDs, configuration details, or personally identifiable information. This can result in information leakage and privacy violations. Denial of service attacks are also a concern. APIs that do not implement rate limiting or resource quotas can be overwhelmed by malicious or even accidental high-volume requests, taking down services or exhausting computing resources. Understanding these threats helps you design more resilient APIs, select the right controls, and reduce your organization's attack surface. Now let's discuss how to implement effective API security controls. Begin with strong authentication. Use standard protocols such as OAuth 2.0 and OpenID Connect, which support token-based authentication and federated identity. In high-security environments, enforce multi-factor authentication. Next, focus on authorization. Use role-based access control to limit what each user or application can do. Apply the principle of least privilege. Only grant access to what is strictly necessary for the operation being performed. Always validate input. Use allow lists to define acceptable inputs. Sanitize request data to remove or neutralize potentially harmful content. Validate outputs as well, ensuring responses do not reveal more than necessary. enforce rate limiting and throttling to prevent abuse, limit the number of requests per second from a given client, and apply quotas where appropriate. This protects your service from brute force attacks and resource exhaustion. Finally, implement robust monitoring and logging. Track all API activity. Alert on suspicious patterns, such as repeated failed logging attempts, access to unusual endpoints, or rapid-fire requests. Logs should be securely stored, protected from tampering, and included in your incident response workflow. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyberauthor.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now talk about secure service integration. Most modern applications are not monolithic. They consist of many services working together. These services exchange data through APIs, message queues, remote procedure calls, and data streams. If these integrations are not secured properly, attackers can intercept data, impersonate services, or disrupt business operations. To secure integration, start by documenting your standards. Define how systems connect, what protocols they use, how data is formatted, and what security controls are required. Use secure communication protocols like transport layer security. For highly sensitive connections, consider mutual authentication, where both the client and the server verify each other's identity. Perform regular testing of integrated systems. Penetration tests and automated security scans help identify misconfigurations, excessive permissions, or outdated components in your integration stack. Adopt secure design patterns. Use service-oriented architecture or microservices frameworks that support container isolation, service discovery, and stateless interactions. These patterns reduce the blast radius of attacks and make it easier to manage security at scale. Provide training for all stakeholders. Developers should know how to build secure APIs. Architects must understand data flow and security boundaries. Security teams must know how to assess integration risks and monitor for anomalies. Let's now examine supporting security controls for API and integration protection. First, deploy an API management platform or secure API gateway. These tools offer authentication, authorization, traffic monitoring, throttling, and input validation at the edge of your network. Use secure identity and access management systems to provision and control access to APIs. Store credentials securely. Never hardcode secrets into applications or configuration files. Use vaults or dedicated credential managers. Conduct vulnerability assessments and penetration testing specifically targeting your APIs and the systems they integrate with. Look for broken authentication, logic flaws, data leakage, and insecure endpoints. Implement secure storage and encrypted transport for all integration data. Whether it's an XML payload, a RESTful JSON response, or a batch file exchanged via SFTP, ensure the confidentiality and integrity of the data are maintained. Maintain detailed documentation and response playbooks. If a data breach or service outage occurs through an API, your team should know what logs to check, what actions to take, and how to contain the incident quickly. Let's wrap up with continuous improvement in API and service integration security. Threats evolve and new integrations are added constantly. Without a plan for ongoing refinement, your security posture can quickly fall behind. Review your policies and technical controls on a regular basis. Stay updated on threat intelligence and vulnerability reports related to API frameworks, communication libraries, and identity systems. Conduct regular code reviews and architectural assessments. Evaluate how new services are integrated and whether they align with your security standards. Engage cross-functional teams. Bring together developers, operations staff, architects, compliance officers, and security analysts to assess and improve integration security. Train continuously. Update training programs with the latest threats, tools, and secure coding practices. Reinforce secure habits through simulated attacks and incident response exercises. Thank you for tuning into the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Strengthen your understanding of secure APIs and service integration, and we'll consistently support your journey towards CISSP certification success.